something like this? Brainstorming. In the head. Okay. This randomly open page here. Oh, here we go. What are we looking at here? Beam me up, Scotty. Who said it? Stand up. He said it. You said he said it.
All of them.
All of them? Okay, I just wanted to know, but I want you to stand up anyway. Okay, come on. Bring your jacket with you. Form and function. What's this the shape of? Jacket. What's its function? What does it do? Keeps it warm. Can someone come up and write jacket up here? And then write the word warm? We're just writing these words down. Later on we'll be able to look at these and generate ideas, okay? Now, this is a jacket. It's in the shape, the form of a jacket. I want you to hold it up. Now, if you were in outer space with these guys leading up, what else could that be? Put it on. A what? Coffee cup. All right, suppose we put electronic gear on here. Okay? A space jacket. And what does a space jacket do? Stand up so everyone can hear you. Yes. Okay, no, come on, no, really, seriously. Come on over here. When anyone's shy, believe me, I used to be just like this, very shy, okay? Look at me now. Can't shut me up. Okay? We're here having fun, okay? We're amongst friends. This is a brainstorming, generating ideas. It's a fun project. So we don't have to worry about being shy, or going to the blackboard or to the paper and writing up something. What did you say? Okay, write that down there. Again, this is an informal presentation. We don't have to worry about spelling words correctly. We're just jotting ideas down so that we can turn them into futuristic artifacts, new ideas. We can take these shapes and forms, take this book, randomly turn to any page. He turns to a blank page. Okay, what do we have here? The Enterprise. Now, how are we going to take this Enterprise, like we said before, and make it actually fly? Huh? That's not a bad idea. Stand up. No, stand up. What did you say? Say it loud. Okay, he was being funny. And that's another way to generate ideas. He said, chuck it up in the air. He's being a smart one. Okay? He said, throw it in the air. But, you know, if you're on the moon and you take something and you throw it, is it going to fall like it does to Earth, or what will happen? It'll keep going. Why? Stand up. Sit down. What? Stand up. Why would it keep going in outer space and not here on Earth? You threw something. You threw a ball in outer space. What happens? Don't be afraid. Don't be embarrassed. It's okay. What's your name? Bishop. I'm Vince. Okay. Now. No. What happens if you do not function? With 2 minutes. Okay. Now sit down. We've seen him on TV a lot of times. Stand up. Stand up. Stand up. Stand up. Can I borrow this? This is a form. It's in the shape of a pamphlet. It has pages. Its function, keep yours rolled up, please. Its function is to read and transfer information. Brainstorm. When it's rolled up like these there, it could be a telescope. Sit down. It could be a, hello, anyone out there? Hello? What's that? A megaphone? Okay. What else could it be? See, what's the same function? Quick. How about a funnel? Pour water in it? So we changed the form and got a different function out of this piece of paper. We'll sit down. All right.
Okay, people, this is now break time. We'll go straight to break. Can you look at the sheets before we go away? In room 102, Mr. Hillier. Remember, 102. Who doesn't know where that is? No one. Good. Thank you. Miss Evans' room 221 upstairs.
All it is ions. Electric. You can't see it here, but the paints on these are fluorescent and phosphorus. You turn the lights off and glow in the dark. Then you put a black light in.
What inspired you to
do this?
Yeah.
Well, I do a lot of hang gliding, flying ultralights, and as an electrical engineer, I used to work with circuit boards. Look at a circuit board, it looks like a little city, like,
Thank you.
oh gosh, probably weeks or something like that to put together. Yeah. You have to wait for the paints to dry. The materials here, it's a, we call it joint compound in the States. Here you call it sort of brown, you mix it with water. What's the name of it? What's it called? Welding? I don't know what the name of it is, but when it dries, you can take a painting knife when it's wet and you can just sculpt it in any form you want. And of course, all the pieces are, again, old turntables, old toys, Christmas tree ornaments, VCR chassis, old motors, recycled junk. But the motto is, junk is a terrible thing to waste. And here we're showing bridging the gap between art and science. We're taking art, putting science together, left brain, right brain, and we're teaching the kids how to be creative in a different way. And again, at the same time, we're teaching them recycle, reuse, reduce. So they're learning about ecology on top of it.
Are you touring or what these inventions are?
Well, I tour from country to country, from place to place. Called futuristic artifacts. That's an oxymoron, meaning future, past, history, so putting it together.
That look cold.
Junk, good junk. It doesn't work. However, when we start taking this apart, there are small pieces inside that still do work. So we're going to, part of the technology is to learn how to reuse stuff that doesn't work. So we're going to look at this form. We're talking about form and function. We're not going to smash it. We're going to take screwdrivers, So, if you have a screwdriver, just start taking it apart and save all the pieces. Don't throw anything away. Remember, junk is a terrible thing to waste. Okay, these won't come all the way out. Take the side panels off. Take the side panels here. Don't worry about these. There's some screws underneath in the bottom. Take those apart. How would I put these in?
Only a small one.
We got all this good junk here. Well, try to be on
We're looking for some rubbish that there's motors and light bulbs and things like that so we can make our models.
Oh, right, so you just do little research, taking bits and pieces out.
Looking for
Okay.
We may have to use our imagination. Which piece of junk to take apart? And now that you have the idea on paper, you can start getting little pieces from the junk pile. So go grab one, like a radio or an old VCR or anything. If it's too heavy, you can help someone carry it over. So leave your paper here, go select some junk and bring it back. There are tools over there on the table. Right. We want to do something with Jesus' energy. When we die, we'll find out about that. So, that's what the name of the objective is, to come up with an idea that generates energy or uses energy. We have to tell you the fire. You want to think of some product, flowers, so very important for you ladies. Unfortunately, a lot of men have said, well, you're not stop. Don't be good.
What's that you got in here? What's that? Video. What are you making?
Okay. Yes, sir. One moment, please. Go with your team. You guys go there and select something with the stuff that you might think is in there to take apart. If it's not in there, that's okay. You can leave it and get another piece. You can't use it. Put up what's about kind of Put up what's about kind of You don't know yet. You what? Huh? What's about rock? Turn it upside down. Okay, we're screws on the bottom. You guys have an extra Phillips over there we can borrow?
about energy, and we're designing and building models which are powered by electricity and any other form of energy that you can get.
And Vince came from New York to Chicago.
So that's why you gather around all the scrap and... Right. How long you reckon you have something live going here? Something properly done? What work?
6-7 weeks.
Take it that long? Alright. Yeah. Right. Now what exactly are you lot doing? Right. Explain in detail.
We're doing like we've gone into that room over there and had to use things that spin around, puffins, electrical, things that light up like buildings with lights. Like in technology, we do the motors, science we do the lights, so we have to put it all together.
How long do you reckon it will take you to have something for the project to be finished?
We've got 10 weeks.
That's all.
Right? This is the creation. Careful, careful. This is a what sort of circuit? A parallel circuit. What have we got in here? What sort of components? That is a... Come on, concentrate. That's a motor, that one. That's an LED and that's a... Okay. Just tell us when that's enough.
Help me, look! You give up my
Calvin. Excuse Calvin.
You're not hungry.
4 yellow LEDs. And we also need one of those other LEDs, the one that flashes for us with a mark on it. Hang on a second, please. Hang on a second. Next, we need 2 motors in each one. And we need 10 wires.
Everything you're working with right now, another part of this project, you'll be taking junk apart. Old radios, TVs, VCRs. You may have some old things at home. Don't take your mom, your dad, television apart at home. But here in the art department, we're going to have some things we're going to give you. When you take them apart, you're going to find LEDs. You're going to find some of these small motors. Those you will be able to take home and experiment with or incorporate into your project. Okay?
So you're going to be using those to make your sculptures and things. All right? Now you learn how to work, you can put them in your sculptures. All right, now let's make sure all your trays are sorted, okay?
The battery socket comes from a company called Radio Shacks. Here you call it Tandy. But we won't have to buy anything. Like, again, like this camera. If we were to take it apart, there's little pieces inside of it that we could make into a battery. And there's wires. And there's a blinking LED. The lenses can be used. So there'll be very little things we'll have to buy. Do you have any old junk at home? Old toys and stuff? You can bring it in, we can take it apart, and incorporate it into your project. Okay? Did you guys get all your stuff put together now? Not sure, Vince. Old VCRs, TVs, old radios, nothing old. Everything's brand new. Well, maybe one of your mates can bring some junk in. And then you guys can... You know a good thing you tell your granddad? Junk is a terrible thing to waste. Good motto. A lot of good reasons. Well, the brain makes electrical impulses. Yes.
In real life?
Yes. It's not that hard. It's very easy. Simple electronics. You can learn about here in class. If you want to work on a project like that, we can do that. You ever see pictures of people in the hospital and they have all these wires to the head, and then you see the needles move? It's an electroencephalograph, EEG. And what it's doing is picking up the energy from the brain and turning it into electrical and mechanical movements. The brain puts out a pulse. It's about 5 microvolts. Very, very small voltage. But with the right type of equipment, you can measure it, you can pick up the voltage. It's very similar to this. You ever walk in the carpet in the wintertime and touch a doorknob, see a spark? It's energy leaving the body. Yeah, like on the astroturf, exactly. Well, the brain produces an electrical impulse, chemicals fire in the brain. You have brain cells. The ends up in the beginning, endites and dendrites. They have a little space in the middle called a synapse area. Then you have a liquid called neurotransmitters. That's something that makes electricity flow. Okay? A neurotransmitter would be like acetylcholine. That's just the name of one of the neurotransmitters. So when you're thinking, each brain cell, actually when you think and move, when you stand there, it's producing electricity which is fed through the nervous system to the muscles. So if I had like an antenna for a TV, beep, 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 if I had an antenna hooked on your head, then I could pick up that energy coming from you. You too. Well, no, maybe there's no brains there. Is there? But each of us, all of us, produce electrical impulses. And you can learn to control those impulses. So you can make, there's 4 types of brain waves, alpha, beta, theta, theta. And that's just different frequencies. It's like when you turn to BBC 1, BBC 2, Radio 1, Radio 2, Radio 4, well, it's different signals. And the brain produces many different types of signals, of which there are 4 basic. And you can actually learn how to control them. And when you control by thinking the brain waves, you can hook it up to a machine. So if you think one way, then the machine will run or it'll stop. It teaches talking. Stretches it that way. But when you take the physical parts that they're going to be working with and they're actually touching it and feeling it, then you can explain the principles and it just triggers. And all of a sudden it just picks up and they start learning. It's called kid-driven. Hand on, mind on. Your minds and hands working together. Because when you were in class, when I was in class, if you just sat and read a book, for me it was dull and boring. But as soon as I got to like science lab and started taking things apart or working with the chemistry sets or the physics, it was fun.
From actual day one, you've been inventing.
Well, I mean, as a kid, and we all know, most kids take stuff apart and reassemble it and that sort of thing. But as an engineer, it's just a little more sophisticated. Then you add art to it, because art is science. And that's why we say bridging the gap between art and science, because art indeed allows the right brain, the visual, to think, okay, if I could make this, what might it look like? That's the shape, okay, or the form. And then the left brain, the analytical thinking, allows us to figure out how, what's driven on the board there. That's the analytical, that's the left brain. Figuring out how it works. That's the function. The form is when the kids were taking the motors and the LEDs and the clips and just sort of experimenting to see how the motors turn in one direction. If you have DC hooked up, positive, negative, and you reverse the polarity, it turns the motor. All those things become so real and so tangible that when they do pick up the books, instead of trying to figure out, now geez, in my mind I'm seeing this wire on the page, and what does that mean if I do this or that? But when they're actually doing it, you actually, as you guys are working here, you'll see the faces. You just watch the faces of the kids when they start taking things apart and do it. And then you yourself, like you say, when you get home, it's a habit. Do you guys have kids at home? Not yet. Well, you do. You know how sometimes parents will say, don't take anything apart. Don't destroy it. Well, let them take it apart. Let them get every little piece out. And then challenge them to reassemble it, not necessarily as it was, but into something else. And that's how discovery, that's where ideas come from.
We're going to ask you just basic questions, right? Just fire away, right? You not comfortable? All right. So I'm going to start with you first, right? What do you mostly enjoy I know you started the project today, but what do you enjoy already from the project?
Science and the art part. The sort of design.
What about you, Trisha?
I like the exhibition. With all the Greek museum sculptures, they're pretty good. Good to see all the things that he made.
Right. Why are you not looking to invent? Or you haven't thought of it yet?
Or we're making a volcano.
Volcano.
Yeah, we're putting the lights.
Are you in the same group?
Putting all the lights in it and everything.
So have you not got the perfect jack, I should say, there?
No, not yet.
Start off? So how long do you reckon it would take you to make this volcano? Give us a rough estimate.
2 weeks.
2 weeks. The last group said 2 months, so you lot seem much more confident.
It's not that hard to do, is it?
Question. Any more questions? Wait a minute now.
I went in the exhibition.
What do you think of it?
I went in it.
Yeah, you haven't been there.
No, I've been to it, yeah.
What do you think about the inventions that American does?
It's pretty good. I like the bubble one, and then we turn the wheel around and produce the bubbles. That's pretty good.
Do you not reckon soon you lot be inventing things in a week like that, or Jack? Or is it?
Hopefully.
You reckon it's going to stay with you continuously? I mean, you can have like old radios, old TVs, and then you're going to be at home say to yourself, right, I'm going to try something here. Can you do that?
My mum and it.
So you plan to let the lava come out of the volcano?
We're not going to have any lava, we're just going to have the lighting and move it around.
And there's going to be, we can get loads of lights going down the side of the volcano and just cover it in red.
And have film and steam coming out of it as well.
Right, so it's going to have, I shall say, the special effects.
Yeah.
Right. Okay, Thomas and Trisha.
Interesting, like, you just go around seeing things move and scenery, it looks good.
What do you enjoy?
Well, I enjoy looking at sculptures and that's very interesting. And that's good.
Right. So how long would you reckon it would take you to invent something out of junk?
Long.
Give me an estimate, a month and a half?
More than that, about 3 months.
Right. How long do you reckon it would take you?
I've concentrated, it would take me about 2.5 months.
2.5 months. You reckon that you were capable to gather your own junk and come here and just do something and get something working?
Yeah, it looks interesting still, but I can't wait to finish it. Because I want to sell it.
What are you making?
I don't even know yet. Because he does some design and science, but I'm not sure yet because we haven't got the junk yet to start making it, so
Right.
I'm not sure.
What would you like to make?
A spaceship.
Spaceship.
What would you like to make, Rena?
Something big and interesting.
Like a Starship Enterprise.
Yeah.
Okay.
First things first, please. Now, I don't normally teach year 9, but I don't want to spend time talking about being respectful to one another and being cooperative and working in the lesson, alright? Don't want to do any of that business. We're going to go straight into the work that we want to do and try and discover certain things. Now, things like coats and bags I'm really particular about, mainly because they can be dangerous in the lab, alright? So coats really should be over in the far corner, bags tucked right underneath. Can you get the energy booklets out and a writing implement of some sort? Up, please, put your minutes. What's our energy source? Food, exactly. The energy source for the stuff we're going to do today, where's that coming from? Electricity. In front of your tables, Devon, in front of your tables, can you see where the source of electricity is going to come from? Where? Tell me. Do you know what that's called? Anyone? What's that thing called in front of you, that little box?
What is it? DC box.
DC box or a power pack, okay? Now, DC box or a power pack. Now, that's going to be supplying your electricity for you. Most of them have got 2 sets of wires. You need to have a set of those 2 wires. try and make sure that the two sets of wires. Now let me see. Can you look over this direction, people? Now they've got one set of wires like that. A group